The Earth is a planet with rich deposits of energy resources. The most important of them is oil. Generations of scientists have reflected on its origin, and most of them seem to be positive on the theory of its organic origin. According to this theory, oil originates from oceans, seas, lakes, and rivers, or to be exact, the plankton existing in water. Dying, the zooplankton and phytoplankton sank to the bottom. Then, for millions of years, they have been covered by sand and other solids and buried deep under sediments. Under the influence of pressure and temperature, the remains of plants and animals turned into the liquid which we now call oil. The deposits that have formed for millions of years are now used by men more and more intensively, and the need is them is growing day after day. But the planet's reserves are limited, and human activity will exhaust the deposits of oil. There is, however, a joint US-Ukrainian company with solid experience in researching the algae that has found a way to obtain a raw material with properties close to those of crude oil, which could be used as fuel for engines. On the basis of Botryococcus brownii algae, the company has developed a method to obtain huge amounts of the algae biomass within a short time. In the flasks, there are prepared seeds, which in the course of growth take carbon dioxide from the air. Then this material is delivered to the so-called bioreactors, filled with water. After analysis, its chemical composition is changed to promote the highest algae growth rates. The prepared water is mixed in the bioreactors with seeds. After that, the water and algae substance is saturated with carbon dioxide. The prepared mixture of water and the illuminating structure made according to the principles of optimal positioning of lamps plus selection of spectral illumination promote the highest efficiency of photosynthesis. In the course of development, the algae, being subjected to a certain shock, start dividing in an accelerated manner, thus accumulating in their mass the maximum of oily liquid, which could be used to produce high-quality oil. After the algae achieve the maximum increment, the whole biomass will be automatically unloaded and separated from water in a special device, the so-called viprocyclone, after which we get the algae biomass containing 7 to 10% of humidity. It is mixed with duckweed, which is carefully milled into the smallest parts. This weed grows in a different block and is then transferred to a container with a catalyst developed by the company Biodiesel. Then the obtained biomass is delivered to the cavitator, a device engineered by Biodiesel and based on the latest high technologies. It has the ability to divide the algae's net at the molecular level and then mix the mass in a precise manner with a catalyst. At the output, we receive oily hydrocarbon mass with a structure similar to that of crude oil. After that, the mixture is delivered to the biocatalytic cracking block, where the fuel is separated into fractions. What is also important is that the carbon dioxide released during the process is collected in a special receiver, so it could be used by algae. As a result, at the output we receive 80% of synthetic diesel fuel, 10% of gasoline, and 10% of jet fuel. This synthetic fuel can be used as pure fuel for internal combustion engines. It should be noted that power supply is independent. It is provided by a gas generator that works on biomethane extracted from the plant called water hyacinth. Moreover, biodiesel has taken a further innovative step. It uses water hyacinth not only as an efficient source of biogas, but also as a high-quality water filter, which makes it possible to breed such demanding fish as the sturgeon, a high-quality food. The technology developed by the company Biodiesel Dnipro has the following advantages, both ecological and economic. Closed process cycle plus economical consumption of power from external sources. Carbon dioxide is not emitted into the atmosphere but goes straight to the bioreactors. It is processed there by algae, which produce oxygen. Separated from water and mixed with a catalyst, the biomass undergoes biocatalytic cracking. Carbon dioxide emitted during this process is also delivered to the bioreactors for utilization. 1 ton of algae can process 2 tons of carbon dioxide. Therefore, all carbon dioxide emissions will be processed by the algae. Absolute similarity to the traditional fuel and the absence of sulfur and lead. No need to use vast areas of fertile soil. Lower prime cost of fuel. And most importantly, there is no need to upgrade the existing fuel production, redesign internal combustion engines, or change the transport infrastructure of fuel companies.